Hi, my name is Neasa O'Connor and I'm the International Recruitment Manager for the College of Science, Engineering and Food Science here at UCC. And today I'm joined by Dr. Conall Kelly and Dr. Tom Caroll, who are the program coordinators for the Masters in Financial and Computational Maths. So guys, I'm just going to ask you a couple of questions about the program just to give a bit more information to students who are interested and anyone who wants to learn more. So first of all, Tom, I might give you this question. So what, in your opinion, makes the program unique?
I think the program is a very broad program, and it covers a number of aspects of financial mathematics and computational techniques, and a number of other related topics in that general area. So students from this program will have a high level of understanding of financial derivatives, a main topic in the course, the standard financial models that are used in industry, and the mainstream computational techniques that are used in industry as well. So the program will also cover aspects of data science and machine learning, and these fit into the general quantitative financial mathematics area. So all these techniques then are brought together in the program in the final research project over the summer.
Okay, cool. Thank you very much. And Conall, the next question for you, I suppose, what industries are graduates working in? And can you give me an example maybe of kind of types of jobs or job titles?
Sure. So the program equips graduates to work in quantitative roles in financial services. Now, this may be something like a so-called quant, who is helping to design trading strategies, or it may be somebody who's working on the regulatory side who is running mathematical models in order to assess risk for a particular type of financial product. So these employers require a specific set of skills, both an understanding of financial models and mathematical models, and also skills in coding. And this is something which has become increasingly important in the last 10 to 15 years. As computational power has increased and computers get faster and faster, they become more widely used in this sector. And so a combination of mathematical understanding and coding skill has become very valuable.
Yeah, certainly. No, we're seeing that with a lot of students we're talking to as well. And I suppose actually that feeds nicely into my next question. So whoever wants to answer it, there's no problem. I suppose data analytics and computer science is a hugely popular field for, certain regions that we recruit from. And I suppose just to give an idea for students interested, maybe primarily in this area, how does your program compare or contrast, or how would you describe the differences?
I think the difference is that this program is much broader than a data analytics or a data science program. I mean, data science and data analytic techniques and knowledge is very much expected in a number of areas, a number of employment areas. And so in this course, for example, students will learn to analyze financial data and to fit models to this data, carry out parameter estimation and similar data analytic skills. So data analytic skills are actually built into the program, but always in the context of quantitative finance.
And I could add to that, in fact, that we've identified machine learning as being a particular aspect of data analytics, which is, again, very recently becoming highly valued by employers. And that is specifically built into the program.
Okay, great. No, that's really good information for people. And again, I suppose the project has come up a number of times. It always really interests students, is the idea of getting to do a kind of project in this area. So Conall, if you could maybe give me a bit of information of maybe examples of what students have done and how they get on with this.
Sure. Now, the way that we run the project here is to give students a chance to take what they've learned during the taught part of the program and then to show that they've mastered it. So we would normally ask students to work in groups, and where possible, we'll ask them to work with an industry partner. So we will have connections with companies who are in this sector and who will have a representative who will work with the group, either to provide data sets or to provide specific training in industry software platforms in order to ensure that the research is relevant to the sector. Now, some of the projects that we've had recently, for example, would involve the application of machine learning techniques, for example, to electricity price forecasting or to credit risk data. So as Tom was saying, that these are data analytic techniques, but they're specifically applied in this financial context. We've also had projects where students who preferred to do some computational modeling, and so they would have been simulating mathematical models for interest rates, for example, and using those models to price sophisticated financial derivatives based upon those interest rates. And what we try to do is offer the students an opportunity to do a project in the specific area that suits them. So if they prefer the challenge of mathematical problem solving, we'll try to set them up with a project for that. If they're very much interested in coding, then they'll have an opportunity to demonstrate that. If they want to focus on machine learning, then we'll give them a chance for that. So we're trying to be as flexible as possible and to align the project with the interests of the student.
No, and I think you have to do that as well, because people will get the most out of it, of course, as well. So my last question to you both, I suppose, is something that often comes up when I'm talking to students is, what do students like the most about the program? And it probably sounds like the project, obviously, definitely could be one of the answers here, but in your opinion?
I think that students like the individual attention that they get. I mean, we get to know all our students very well, and we have a personal relationship with our students. So any difficulties students have or any advice that they need, we are always there to help them and to work with them so that they get the best out of this program. The various cohorts as well, have always seemed to gel very well together, and they help one another out and really develop a very positive and a very engaging class dynamic. So I think they enjoy coming to UCC, they enjoy Cork. It's quite a friendly place. So I think they like those aspects of the program.
And I think that the feedback that we've gotten from past students is that the particular combination of mathematical problem solving, coding, and machine learning it seems to blend well together. And for students who are interested in those areas, then they get quite a bit from it. And we've had students say in the past that they've very much enjoyed the cross-section of skills that they've gained from the course.
Okay, great. Thanks for all your information today, guys. I really appreciate it, and I hope the students will get a lot out of it.
Lovely.
Thank you very much.
Thank you very much, Neasa.